In order to determine the bulk density of coarse aggregate, we're going to use a container of a known volume. The way we get to know a volume of a container is we measure it with water. We know the specific gravity and density of water. If we know how much water this container can hold, we can calculate its volume. In order to do this, it's really simple. You take the container, you weigh it empty, and you weigh it full of water. To ensure that the container is full of water, we're going to use a glass plate to skim off the top and make sure that the container is filled all the way to the top. Now, in order to make sliding the glass plate across the top easier and to make it waterproof, we're just going to take some simple petroleum jelly, rub it along the top of here. Before I add water to it, I'm going to take the glass plate, I'm going to set it on top, and I'm going to set it on top of my field scale. I'm using this scale because it can go up to 130 pounds, which I know will be able to easily hold the container, the glass plate, and water. Over here I have some other scales. This one can do about 5 pounds, and that one can do about 25 pounds. I know that this whole setup will be getting close to the 25-pound mark. So first, I'm going to take a measurement of the weight of the container and the plate. So the container by itself weighs about 17.52 pounds. Now what I'm going to do is take the container and fill it with water. An important thing to know is the temperature of water, because as water's temperature changes, its density changes. So I've had this thermometer in here for a good long time. Unfortunately, it's in Celsius, and right now it's reading 25 degrees Celsius. So I'm going to go ahead and I'm going to fill this container all the way up to the top. I like this pitcher, so I'm going to save the end of it. Bucket. Now when I get to the top here, I want to fill this all the way up to the meniscus, right to the top. In fact, I need to get a little bit more water to fill this in. And then when I get the meniscus of the water just over the edge, what I'm going to do is take this plate and slide it from front to back to make sure I don't get any air bubbles in there. And now, if you did it correctly and you're looking down from the top, you'll be able to see that there's no air bubble held under the plate. So what we need to do now is lift this whole thing up now, which has become very heavy. Put it on my scale and find out how much it weighs. And we are way over the 25-pound limit my other scale had, so I'm glad I used the field scale. So according to my field scale, this thing weighs 48.7 pounds. Now, using the temperature of the water to determine its density, I can determine the total volume of this metal container. And then I can use it to determine the bulk unit weight of the coarse aggregate. So now we're back the next day. We did everything we needed to do to determine the volume of the container, and we've let it dry overnight, so now we have a nice dry metal container. And we have the information we need to determine what the volume of this container is. What we're going to do now is take our coarse aggregate, fill this container absolutely to the top, and weigh it. And since we know what the volume of the container is, when we have the aggregate in here, we'll be able to determine the bulk modulus of the container, of the aggregate. Now, we can't just dump the aggregate in. What we need to do is fill it in here and compact it. And there's multiple ways that we can compact it, but we're going to use the rodding method. So in the rodding method, you're going to fill the container in 3 lifts in thirds, so 1/3, 2/3, and then full. And at each third, you're going to rod it 25 times. On the first layer, when you rod, you don't want to go through and touch the bottom of the container. You want to rod into the stone. On the second layer, you don't want to rod into the first layer. And on the third layer, you don't want to rod into the second layer. So I'm going to start filling here and rodding. Now, the sample of stones has been dried in a 110-degree oven for 24 hours and let it cool, so there is no moisture in this stone at all. So when I get to about a third, I level it out, I take my rod and I rod it 25 times. There's 1/3. Now for another third. Third, another 25 rods. Now, an important part of this is that you want to fill it all the way up to the top. And you want to compact it down. So I'm kind of just rolling it around with my fingers here. I'm going to get it close, I'm going to rod it, and then I'm going to come back through. So now comes a little bit where you jiggle it with your hands, flattening it out. You want to get everything, you want to get it filled as much as you can and get everything down below the lip of the container. Because we know the total area of the container, but if stuff is sticking out of the container, obviously it's going to mess up the calculation. So you can use a straight edge. I tend to use the rod to run it across the top, and you can see it kind of skims off rocks that are sticking up, and also knocks some rocks down that are not sticking up. So I'm going to skim these off the top and see if I can get them to fit in to the container a little bit better. Obviously is some room for adjustment here. In the thing, when you use the rod, you can roll a little so you can see where you might have some people sticking up. And you can look and see where you get people sticking over the top. When you can pass a straight edge over fairly well, you know you got everything down. So, once you have everything compacted, all there is to weight it. So this whole thing altogether weighs 63.50 pounds. And just because I forgot to push record, before I added all the aggregate to this bucket weighed 12.69 pounds. So empty, 12.69 pounds, filled with this stone and compacted, 63.5 pounds.